Okay, let's get started. Can you hear me well in the back? Okay, you can't. I'll try to speak up. I'll do my best. I'm excited that there are so many of you here spending your private time to learn something new and to meet people. Actually, this is why I like to attend conferences like this. So I'd like to share with you a few impressions from Gophercon Europe conference that took place in June in Berlin this year. By the way, has anyone attended Gophercon so far? Okay, so I'm in a good place then. So Gophercon started in 2018 in Reykjavik, so pretty nice place to go for a conference. Then it was moved to Tenerife. Then during pandemic, it was held twice online, and then twice in Berlin. It consists of a workshop which lasts one full day, and there are 2 full days of conferences, of prelections. And generally, topics it revolves around is Go, like Go development, Go optimization, but also cloud, Kubernetes, so most cloud-related stuff, but also it's various kinds of databases. We'll get to that. It was held in Festsaal Kreuzberg place, which turned out to be a great place to host a conference, but I'll get to details later. So it started with a full-day workshop, and this is a link with a description if you'd be interested. There were 4 topics. One about gRPC, the other about creating ultimate service with Kubernetes, building CLI tool, and object-oriented design. Initially, I signed up for the first one. So where's my mouse pointer? For gRPC. Unfortunately, it was cancelled a couple of days before a conference, so I reassigned myself to Ultimate Service with Kubernetes. I was also really interested in object-oriented design with Go, which was led by Rona Steinberg. But I couldn't attend both. But there is a prelection of Rona that she gave at FOSDEM conference in Brussels. It lasts about half an hour, and it's extremely interesting, at least to me, because it's a bit controversial topic if Go is object-oriented or not. And Rona elaborates on that pretty well. So if you're interested in this area, here's a link to this conference. And by the way, in Brussels, it was a conference for free, but it was transmitted online. So you can also watch other prelections there. It took 2 days, but Go track lasted only 1 day. So the workshop was led by Bill Kennedy, this guy in the center. And Bill works for Ardon Labs company, which gives trainings and conference talks. And Bill turned out to be a really knowledgeable guy. He presented a lot of material, there were a lot of people, which was kind of a disappointment on the other hand, because there was no place to sit for everyone, as you can tell. Not to mention even enough number of power plugs for your computer. So it turned out not to be a workshop, in fact, but more of a hands-on presentation, because Bill would talk on a certain topic, then he would sit at his desk, type something at his computer, and then push it to Git repo, which allowed you to pull it later. So it was impossible to follow him implementing something. So you were able only to pull increments of his work. I was a bit disappointed with that because I counted on a workshop in a university manner. And the other workshops turned out to be like that. There was a dozen, maybe 2 dozens of participants, and a leader had time to, come up to each desk and help a student. But this one was overcrowded, probably because the first one was cancelled, so most of them were assigned to this other one. But regardless of that, workshop turned out to be pretty interesting anyway. And I'm going to present various areas and various thoughts of this full day workshop to just give you a bit of a flavor of how it looked like. So the aim of this workshop was to build an app skeleton where you could add your business logic later. And it was an example of deploy first mentality. So before a workshop, Bill sent out a repo with content that we were going to work on together. And then during a workshop, he started with presenting app skeleton. It's a repo structure, because Golang committee doesn't offer any guideline on repo structure, so you need to work on your own on that. So Bill proposed such a structure, this first line, with 4 layers. Vendor being third party, Zarf, which made him really happy because he invented this name to be used here, because Zarf is a paper slip that you use to cover your paper coffee cup so you wouldn't get burned. So it isolates you from the heat of coffee. And here, similarly, this Zarf directory name isolates you from Docker config files, YAML files, and other stuff like that. Foundation layer is very general. Technically could be used in another project. Bill uses here a bit different nomenclature from standard domain-driven design. And then business and app layers. Later on, Bill elaborated on various topics like login, metrics and traces, error panic handling, middleware functions, and number of routines and core utilizations. So after you have a repo structure and covered metrics, login, traces, and handling of various stuff, then you're ready to prepare your business logic. So it takes a bit of time to prepare all of that. Bill was using various tools for his presentation. I just named a couple of them here that were the most interesting to me. Kind was primarily designed for testing Kubernetes itself, but can be used for local development as here too, and CI. Customize is available both as a standalone binary and a native feature of kubectl apply. And Go Max Procs. Bill had his Mac M1, which displayed 10 cores, but he was running this service in a Docker, in a Kubernetes based on Docker, configured to 4 cores. So his Go Max Procs was set to 4. So Bill elaborated a bit on Go concurrency, Kubernetes, design philosophies. Actually, he was talking a lot. He presented this link to his repo, in case someone didn't pull it yet. You might want to take a peek here, because it's quite useful. You might find something useful there. He presented also his config package that he created that allows you to parse CLI arguments and environment variables. And it provides you with default values mechanism, password masking, it's help ready. So it's much of help for such a configuration. And the last link, it's his course on Go. It contains lots of materials on Go, and I found it quite useful too. Okay, let's dig in a bit into few of areas that Bill mentioned. So, your work is either CPU bound, like calculating pi number, or IO bound. And CPU bound hates context switches because then it just waits for it to end. But IO bound loves it because you can do other stuff while waiting for IO. And Go scheduler is great because it transforms IO bound operations to CPU bound. And it does it because it makes user space threads, so Go routines, context switch, and not kernel threads. But should we care about context switches? Well, on average, you can say that kernel thread context switch takes around 1 microsecond. It doesn't seem so much. But if you translate it to number of CPU instructions, you get number like around 12K, which is quite a lot. And it would be nice if our CPU could do 12K operations instead of waiting for a kernel thread to switch. So his first advice is that you shouldn't set more kernel threads than cores, because then you hurt your scheduler and force it to do kernel switches. This is pretty obvious, right? It's not so obvious in a distributed environment because you also shouldn't set your pods to maximal number of cores because then your pods would be competing for resources. So Bill proposes two strategies. First is don't worry and set your number of kernel threads to some value and don't worry, it will work some way, and it's quite good for bursts of load. Another approach, quite interesting, is to run another instance when performance hits. So it's an example of horizontal scaling. In order to do this horizontal scaling, you need to set GoMaxProx to 1. So there would be no context switches between threads in each pod. But actually what Bill proposed was to limit each container CPU time to only 1/4 of time, so to 25%, and have Kubernetes add another instance when load increases. So it makes your program a single threaded program with concurrent routines, but that could be scaled horizontally. So it was a really interesting approach that I haven't heard of before. Couple of other thoughts. CGO enabled flag was set to 0 to avoid dependencies to OS. And here was quite a clever mechanism to identify your binary during runtime. In main Go, you have global variable build set to some default value. In Docker file, with argument parameter LD flags, you set main.build, so you set this global to build-ref, and build-ref is set to version in makefile, and version is set to some string plus git commit. So it allows you to automatically embed a binary version in a binary itself. Quite a clever mechanism. Couple of other thoughts. Interfaces are just structures with type information and a pointer to concrete type. Itables are similar to vtables in C++. You shouldn't return an interface from a function, like for HTTP handler, but a concrete type. A user can always use an interface for that, but they shouldn't be forced to do so. Libraries you use shouldn't close your application via OSExit, panic, anyway. It should only tell that it thinks that you should close your app and it should do it by returning shutdown error type, which you could handle, and you then take a decision if you close your app or not. And actually, in one of Bill's projects, he had such a problem that his application was each time terminated by external third-party library. Bill said also that he thinks that a single developer can maintain only a mental model of 10K lines of code. So it means that a project with 40K lines of code should have 4 developers. Engineers in his projects are not allowed to use debugger. I mean, they are, but only for first 2 weeks to learn the project, but later on not. And it's because they are allowed only to use what's available on production. Pretty controversial, but it's his approach. Usually parent coroutine should not shut down before child coroutine, as a general rule, but there are exceptions. For example, pprof coroutine or debug coroutine, we don't want to hold closing your application because it doesn't make sense. And interesting fact to me was that during years 2010, there were router wars, so-called. And it was a period of time where everyone was creating their own implementation of router. And people were arguing which one is faster, and it was order of magnitude of 1 microsecond or even less. And Bill argues that you shouldn't focus on that at all, because your performance doesn't suffer because of router. You should just simply pick the one that meets your functionality best. And if you have performance issues, then you should do some profiling, check where you have bottlenecks, and it will probably be your code or database and not a router. In the end, he elaborated a lot, like for too long, on simple concepts like errors being propagated down function call stack. Okay, so this workshop lasted from 9 to 5. So I was pretty exhausted, but it turns out that there is a meetup group meeting of Gophers in Berlin at Google's office. So I headed there. And it lasted for another around 4 hours. And it was about Service Weaver. Unfortunately, there was no introduction because it was a workshop. And I got there a bit late, so I was not able to fully participate. But it was not a waste of time because there were some drinks afterwards and, Google's office in Berlin. But luckily there was a presentation the next day on Gophercon conference for the same topic. So luckily I'm able to present that. So this presentation was led by Robert Grundle, engineer from Google team at Go team at Google. And Robert started with explaining microservices, which is architectural approach where you split your application into independable, deployable binaries that communicate with each other over network. And actually there are quite many tools that support microservices, right? Like Docker, Kubernetes, Prometheus, OpenTelemetry, various kinds of databases, queues. And quite often, a decision emerges whether you should use microservices or a monolith. And it's not an obvious choice. It's all about trade-offs. But we are often biased by the fact that big tech companies publish papers on how their migration from monolith to microservices made them save thousands of dollars. So it should be pretty simple, but you can also find other kinds of articles, like AWS saving 90% of costs by porting Prime Video from microservices to monolith. So actually there are no clear guidelines, and there are many trade-offs that include costs of development, deployment, testing, observability, performance, fault tolerance, scalability, maintainability, portability, and other buzzwords. But your decision should result from technical benefits, not from bias. And it's pretty hard to take such a decision in the beginning of the project. And when you do, there is a lot of investment with a certain approach. Monoservices versus monolith, and it's hard to change approach later on. So Robert's team created this Service Weaver, which is a programming framework for writing and deploying cloud applications that creates a modular binary. And its main power is to delay deployment type decision and allows you to focus on business logic from the beginning. So you can deploy your application as a single process monolith or multi-process monolith, or as a set of microservices running on one node or multiple nodes. You can deploy it locally, remotely, in cloud, and it's multi-cloud. And it offers quite vast area of functionalities, because there is deployment, obviously, orchestration, replication, sharding, caching, metrics, logging, tracing, and also great performance and latency. So it seems like a silver bullet to all our problems. Let's see a real example of how it works. So in order to use this framework, you need to split your application into components. So you create a simple interface. You create a struct that you will use to call functions. And you create a receiver function. You implement this interface. So this is native Go implementation. In the next step, you call your components. So you still are using your native language constructs. And then there's deployment phase. So you can deploy it in various ways, in a single process, multi-process in the cloud. And you use tiny config files for deployment. I didn't place them here, but they are really single liners or two liners. And in the end, you have your services spread or not across number of machines. And actually a decision whether components should use direct method calls or network calls is delayed until this phase. And even when you take such a decision, it's super easy to change it later, because you give responsibility for that to Service Weaver, and it generates code under the hood and takes care about all of that. Here is a slide that I stole from Robert's presentation that shows online boutique application, which is a demo from Google's GitHub for microservices. It's written in Python and C# and a bit in Go. So Robert ported it to Go, and it runs on 11 microservices. So Robert ran it in a classical way, using microservices, Go-based microservices, and using Service Weaver. And he compared number of code lines and number of cores or CPU usage and latency. So for number of code lines, it's not super impressive here. It is a bit when it comes to config code, because Service Weaver has super tiny configs. And here we get rid of all YAML files. But results in CPU usage and latency are quite impressive, because it's 1/10 for both while using Service Weaver. So it seems to be not only convenient but also super performant. So here are two links. First is a web page, and second is Git repo. Here's a link to this prelection if you're interested into more details, because it was only a brief overview. Here are a bunch of commands that you use to run your service. And to summarize, this project started around 2 years ago. It was open sourced in March this year. And right now they are gathering feedback for direction, and of course encourage to contributions. Okay, so it was the end of the first day of workshops. The next day, actual conference started with prelections. It started as usual with a keynote. Keynote was given by Cameron Balahan, the product lead for Go at Google. So Cameron talked about Go history and plans, and he started with quite famous quote of Rob Pike, who in 2007 said, "Did the C++ committee really believe that what was wrong with C++ was that it didn't have enough features? It would be a great achievement to simplify the language rather than to add to it." And Rob said this during one of Google's presentations, where they were listing 35 features of C++ 11. I was super excited by C++ 11, by the way. So it's a surprising other approach to discover. So Go idea was born around the time during 45-minute C++ build. And at that time, Google had a very quickly growing number of employees and projects at scale. In 9 years, they grow by 30 times. And at that time, Google was mostly using C++ and Java. And probably you all know that, especially C++, it's not the easiest language to start with and work with. You can do anything with it, but it has its costs. And Go is designed for software engineering at scale and projects at scale, where people come and go. So it's supposed to be super easy. So a bit of a timeline. It was born in 2007, then open source, then had a bunch of major versions. Most important here would be 1.5, where its compiler was completely rewritten in Go. Modules were introduced. 1.18 contained most significant changes, generics included. And in a couple of months, in February, will be another version 22. So with 1.18, given that it contained most significant changes, there was a chance and a temptation, actually, to fork Go 2.0. Because there were some discussions if it should happen or not. There was a backward compatibility promise until the time when there would be Go 2.0. But we all know what happened to Python. So Go team took a decision that there will never be Go 2.0, and backward compatibility is a promise. Other main theme of this presentation was that Go is actually not a programming language. It is much more, because it's a whole platform that provides user experience with CLI as a so-called developer touchpoint, with VS Code extension and Go Please language server, and testing, benchmarking, and profiling and fuzzing mechanisms embedded. So all of that works out of the box. And it is highly coupled with cloud because Go was designed around cloud as it was being created in the same timeline, more or less. And cloud is built with Go. Let's start with Kubernetes. And Go generally targets new applications. So that's why Go is really coupled with cloud. And the Go team works extensively on both language features, CLI tools, and VS Code extensions. So engineers could easily use all of that from the very beginning. It's quite the opposite from C++, where there is a feature created, then it's implemented, and then it needs to wait for IDE support. And two charts that I took from Kamer's presentation. The first one shows number of GitHub pull requests. Here we have Java in yellow and Go is in red. I'm not sure why C++ is not listed here. But it's quite interesting that Go almost ties Java. And here we have Go's user base, and we can see that it grew around 3 times between 2018 and 22. So number of Go users is growing really fast. So all of that says that enterprises adopt Go widely. So attacks on Golang can be particularly harmful. So that's why future of Go revolves around security, easier onboarding, because there are so many people switching to Go, and minor things like more generic usage in standard library. Okay, next presentation was led by Julie Q, another tech lead from Google, from Go security team. And Julie started with a question, what is a vulnerability? And it is a quality of being exposed to an attack or a harmful action. There is a nice TEDx video by Brené Brown with over 60 million views, and she elaborates about vulnerability. It's more social and emotional vulnerability, so it's kind of different, but still a great talk, 20 minutes. So why Go team cares so much about vulnerabilities in Go? There are a couple of reasons. The first one is that in 2021, Joe Biden ordered an executive order on improving nation's cybersecurity. So they are kind of forced to do so. But the other is that supply chain attacks grew over 6 times within 1 year recently. So, what is software supply chain? Julie started with an example of cake supply chain, where you have cake ingredients like milk, flour, eggs. You have equipment needed to prepare a cake, like oven, bowls, a spoon. And in order to ensure that a person who has celiac or something, so can't eat gluten, you need to check each piece of your cake supply chain. So every ingredient, every piece of equipment, if it is gluten-free. So a similar case happens with your software supply chain. You have your code, which you should know, but you have a number of packages that you include in your project, and you have no idea what they contain. So you should check all of that, single line of code of your packages. You should check also each tool you are using. And you could do that to start with your packages. You could manually check all the packages in your Go mode. Maybe not go through each line, but you could just compare this packages list against a third-party vulnerabilities database. But it's a tedious task. And actually there are tools that do it for you, like Dependabot on GitHub. It sends alerts when it detects that your repo uses a vulnerable dependency or malware. So this is pretty impressive and useful. But you don't want to solve your 15 vulnerabilities in your short code, and you're not supposed to do so because probably most of them doesn't even impact you. You're supposed to fix vulnerabilities that impact you and ship your code. That's a problem that Go team tries to solve. So solution they came up with is called GoVulnCheck, and it's a static analysis tool. The way it was created is that they created Go vulnerabilities database, and this tool detects vulnerabilities in your code based on decision is certain vulnerability on your execution path. And it reports only vulnerabilities that are, and only informs you about others. So this is a simple diagram for this tool. The database is kept at vuln.go.dev address. It pulls information from various sources, and it has 4 interfaces. Command line tool. It displays clear information on package go.dev webpage with red label if there is any vulnerability. It provides VS Code extension that shows you vulnerabilities in your IDE, and it provides also GitHub actions. So the way it works is that if your code imports module A with package A, that imports package D from module B, that has package B, that imports package C from module C, and you are using only package D, so package C has a vulnerability, but it's not on your code execution path, then package C issue is not reported. So it suppresses noise of vulnerability detections. Let's see in practice how it works. You installed it with this command. It's still in experimental phase, and you run it like this. So this is output on the right that contains a couple of information. Summary, how many vulnerabilities and how many modules. Details of each vulnerability. Link to its description. Found fixed versions. And actual call stack in your code, so you'd know which line calls this package. Other bunch of information contains other vulnerabilities that packages you import contain, but they are not on your execution path, so they don't require any action on your side, unless you're interested. And here's again a link to the video. The next presentation, I have only 2 left, is by Jonathan Amsterdam, another Go team member. And he elaborates about slog being added to Go 121 in August this year. And this is pretty big thing because there is already a standard library logger in Go, but it lacks many functionalities. Like it doesn't have any levels, doesn't have on-off configuration per package, and doesn't offer structured logging, so key value pairs. So its usage is pretty limited. So as always, when there is something missing from standard library, people implement their own versions. So in 2014, Logrus was created, widely used but slow and not maintained anymore. 3 years later, it was replaced with Zap, which was much faster. And later on that year, Zerolog was created, which was even faster, which was awesome, but it had use after free bugs for some rare cases, but still. So slog decided to aim for Zap performance, so it wouldn't present this use after free bug. And Zap is extensively used in projects, so it seems that it has just sufficient performance. So slog offers 2 ways of logging. Each way allows you to define a login level, message, and then a variadic set of key value pairs. First way requires you to use a special function related to login level, and then there is message and key value pair. The second way is log address, requires you to pass login level as an argument, and then message, and then there is a key value pair in the form of a record. And this way is actually more efficient. So if it counts for you, then you're supposed to use this way. Many people prefer this way anyway because you have key value pairs binded in a type and not spread here, so you are not misled which one is which. There is also a logger with function that allows you to pre-process arguments, so it becomes part of logger, and it's very efficient because, especially for big objects like logging whole request, because we want to parse whole request once and log it each time we are logging something, and not to parse it each time. Okay, so it took them 10 years for the logger to appear in STL. It seems quite insane, like 10 years for such a basic functionality. But Alexander argues that it gave them a lot of information they could use. I mean, it was 10 years of industrial experience. So they could measure, and actually they measured a lot. For example, they checked that 95% of use cases pass up to 5 arguments to a logger. So 5 became their gold number that they optimized logger around. Another result is that most of cases uses just a couple of times. You don't need to have a couple of dozens of types. And generally they focused on slog to achieve high performance and low memory allocations. And high means Zap level. Typically you can have thousands of logs in your code, so it is supposed to be quite efficient. So the way they achieved it is by avoiding indirect calls and avoiding heap allocation. Heap allocation is very expensive by definition, and we prefer to have stack allocations. And calling functions through an interface or a function pointer suppresses compiler optimization, because despite a pointer jump, compiler doesn't know which code will be called later, so it doesn't see it in a single view and can't optimize it. And so they made good benchmarking to check if their logger is quite efficient, mostly for up to 5 parameters, but they tested it up to 40, I guess, to be sure that there is no performance edge or something. And here are concrete ways that they used to achieve high performance. So first one is that logger is a concrete type, not an interface, to avoid indirect calls, but also to avoid heap allocation, because if a logger was an interface, then even if you had in your code debug function, which typically is disabled, you just enter it, check if it's enabled, it's not, so you return. But then you have variadic parameters for this function with key value pairs, and they would be allocated on a heap, even for disabled functions. But for logger as a concrete type, it's not the case. They're allocated on stack, so that's fine. They did a lot of escape analysis to check each case where something could be allocated on stack. They used sync pool to avoid memory allocations at all. I mean, to allocate memory only in the beginning and then reuse this memory. They are passing records by value, and values need to be pretty small, and if they are big, then you use this logger with mechanism to pre-process a request a single time. And the last one is pretty clever, because for outputting information from logger, they could use a slice, but slice would be heap allocated. So they used an array, which is stack allocated, and size of an array is 5, because they know that it covers 95% of cases. And there is also an empty slice that is kept on a heap, but for most of cases is empty, and if needed, it can be filled with values. Yeah, here's a link to this collection. This slog is already present in Go 121. This is more of a tale. It was led by Maciej Rząsa. He's from Rzeszów. And he specializes mostly in Ruby, but his experience is applicable to any project. So, once upon a time, Maciej had a huge question. Should he deploy on Friday at 4 p.m.? Quite a tough one. And he presents a very interesting use case. It's kind of a share my experience story. They had a monolith in Ruby, and their aim was to split billing part out of the monolith. So it sounds pretty familiar, to Splunkers especially. They created a few steps for this journey, quite reasonable, because they firstly separated logic of this billing component. So it was the same process using direct function calls. As a next step, they delegated it as a macroservice, because it was pretty huge, communicating via REST with feature flag and fallback mechanism to direct function calls. So they were pretty defensive. And feature flag actually allowed them to switch only a certain percentage of clients to this new approach. As a result, it was a performance disaster, because they had requests flood. So they were quite clever. they came up with an idea to replace REST with GraphQL. So they were able to decrease number of requests from thousands to tens. They also enhanced monitoring. They were logging each request, its arguments, stack trace, response time, so they would have a short feedback loop. And it was better, but still they had poor performance because they had many database requests. So they came up with another clever solution using Kafka. But then one of the more experienced guys came up with a kind of a hack that they could just use a domain knowledge and reach out to a database from Berlin to a database of the other monolith and retrieve this information. It wasn't pretty, but it was quick, so they went with this hack. After all was done, they were ready to deploy. So we are coming back to Maciej, Friday 4:10. He was quite brave or stupid, not sure, but he deployed to production, and he was browsing Slack channel. So he started seeing messages about from single customers complaining about service degradation. After some time, his colleagues in the US started doing the same. Then CPU and memory usage skyrocketed, and then platform went down. At that time, he realized it was his deploy, so he stayed long hours to fix it. Luckily, he had a lot of help from DevOps team who volunteered to stay late with him. And actually, they made a rollback even before he realized that it was his code. So he was pretty covered by his DevOps. After some time, he found what was wrong. He refactored the code to sanitize DB parameters too eagerly. And if request didn't contain any parameters for filtering, he was fetching whole database. So each query lasted around 1 minute. He fixed it, so it would be end of the story, but on Monday his manager approached him and actually thanked him for his work, which took him by surprise because he was expecting one of these manager stocks. But he heard that it is okay to fail in fast-paced environment as long as you fix the failure. So it's not just enough to have proper tools for fast-paced environment like rollbacks, but it's also important to have a safe environment at your company that lets you make mistakes and encourages you to have a proactive approach and taking responsibility. So, to summarize, they had quite well unit tests present, but they were testing only one parameter that was not sanitized in this execution path, so it didn't detect it. They had integration tests, but they were switched to GraphQL path, leaving REST untested. So Maciej finished this talk saying that he should have tested his code manually before deploying it to production. That's what was missing. And the other thing is that he was lucky enough to have short feedback loop due to quick rollback mechanism, logs, traces, feature flags, and fallback mechanism. It allowed him also not to impact customers so much. And his main conclusion from his talk is that you are even supposed to fail softly quite often, so you could learn along the way. Okay. This is the last talk that I will present here, and it was a panel with Go team. Here you have 6 members of Go team, and they were asked questions from the crowd. So I listed just a couple of them to give you a flavor of what this talk was about. Underappreciated packages, fuzzy testing, IO test, testing quick, and metrics. If they could break Golang backward compatibility, they would add more interoperability with other languages, like the same way like Kotlin leverages Java. What traits should have a senior Golang engineer? And the answer is quite simple, because it's the same traits as any other senior engineer, because Golang is super easy, super simple, and it doesn't require any special skills from you. Plans for future of the language, maybe rethinking errors, and security, Govul check package. It will be released in February next year. Generics currently can't be used for methods, and they hear a lot of questions. Why is it so? And if they find a feasible technical way to do it, they will. But currently it's hard for them to do it. Is it possible for Golang to lose Google support, and would it matter? So first part of question, probably not, but they're not CEO. And second question is no. But they are verifying new Go versions against Google code base currently. So it turns to be really helpful, because they are detecting many bugs. Flutter and Dart, on the other hand, don't do it, and they have many bugs in production actually. The next one is pretty typical. Why don't you standardize testify package or add assert expect functions? And they don't want to create new kind of language for testing. And they don't want to add simple algorithms like linear search, accumulate for slices. You need to do it by hand, just simply iterating. And the answer is pretty surprising, because they don't want to have too many interfaces that would be holding them back in terms of backward compatibility. But if there is a pressure from users, they might add it. And here is a link to Prelection, if you want to watch it yourself. So to summarize, it was a 3-day conference, 1-day workshop, 2 days of Prelections. Workshop was additionally paid. So there were 2 types of tickets. And the next day there was Google user experience team interview. They were not interviewing for jobs. They were gathering feedback about Go usage. And videos, all videos for Gophercon are available here on YouTube. When you type Gophercon Europe on YouTube, it will be the first link. And to each presentation, I placed a link after that. And here in QR code, you have a link to this presentation if you wanted to go through it again. So generally, it was a great conference with great people, funny MCs. There were many Golang recruiters. It was slow-paced, because I had time to recharge between lectures. And it was quite nearby Krakow, 6 hours drive. Other topics that I didn't cover in this presentation, but were covered on a conference, are around WebAssembly, writing time series database from scratch, how to cut memory usage by 80%, and advanced concurrency techniques, and some others. After the conference, there was a small party with live music, which was pretty nice to participate in while waiting on my Flixbus. And next Gophercon will be in February in Greece and in June in Berlin. So if you attend that, please come back here and give us a talk. Thank you. Do you have any questions?